Hello everyone, welcome to the Go Code Snippets channel. So in today's video, we'll be looking at some gotchas and quirky syntax in the Go programming language. So these are the ones I was able to highlight. So basically everything here is not, obviously this is not everything that I've actually experienced, because this video is actually based on those ones that I've actually come across, and also I actually highlighted them here. But this is obviously not everything, but these are the ones that I was still able to just remember, and I decided to just list them down so I won't forget them. Obviously there are more, but these are the ones that I was able to remember as at the time I was recording this video. So before we move into the video, I would like to actually mention one thing, that if you are new to the channel, please make sure you subscribe to the channel. And if you are not new to the channel but you've been watching videos, I really appreciate it if at this point you consider subscribing to the channel, because it actually helps me to get my videos out there, and also other people out there get to have access to stuff like this. I mean, we can also help the good community grow. If you're a Go lover like me, this is actually a chance to help the Go community grow and all, because if you look at mainstream languages out there like Python and JavaScript, they actually started from somewhere, and Go is actually taking the industry by storm. But then we can still do more to help the Go programming language as a universal language. So with that, let's get into the video. So the first thing that we'll actually be looking at is the continue statement, which is this here. So the way the continue statement works is, let's say for example I actually want to print numbers from 1 to 10, or from 1 to let me say 1 to 10. So let me say equals to 1 from 1 to 10. So I will do print line I, and I'll say if I equals to 7, so I'll just give it a continue block, a continue, then from there, yes. So this is what I just want to do. So for me now, I'll format the code. So let me just clear up my console, then I'll run the code. So at this point we're having 1 to 10, everything is going on fine. But if I cut this line here, this is my print statement, I cut it and I put it here, and I run the code. So this time around the runtime actually skipped 7. So I skipped 7, so from 6 it went to 8. And the reason is because the way the continue statement actually works is, after a continue block is being called, or for some reason a continue block is executed, anything after that particular block, for example in this for loop, won't be executed. So what that simply means is that when this was up here, actually because it wasn't called after the continue block, it actually executed and 7 was printed. But now that it is down here, because the continue block was executed when I became 7, so it won't bother printing 7. So you might be wondering that what is a good use case for this, and I actually thought of one just to explain things better. So let's say that I actually have a slice of string that is holding numbers as strings. So I'll just say 1, 2, 3 and 4. So I just want to add all these numbers up, so I'll just declare a variable total, and it will be an integer. So what I'll just do is so I'll range over the array. So for underscore, I need just the values should be equal to range n, or let me call it nums. So what I want to do is that first of all I'll get the number, and I'll do string conv, ask it to int. So I'm just converting each value into a number if I add this to total. So I can say if error not equals to nil. So that means if there's an error, which will most likely occur if this particular string is not a number, say it's a for example, which is a letter, or any other thing that is not a number, that is when an error will occur. So I'll just simply print printf. I'll do %v is not a number, then I'll pass in v, yes. So else I'll just simply add total to n. So at the end I'll just print out total. So yeah, instead I'll say else, sorry, I should actually put in an else block. It's actually better if I put in an else block. So I'll print total. So if there's no error, if there's an error, that means if whatever is here is not a number, it will print out this. But if there's no error, if it is a number, it should just add it to total. So for me, I will run my code, format the code, then run the code. So I'm getting 10, no problem. That is 1 plus 2 plus 3 plus 4. But say I actually change this to a, for example, now. Then I print it out. So I'm having a is not a number. Then I'm having 8, which is just the addition of 1 plus 3 plus 4. Let me just put a backslash here. So actually, it's actually a good way to go about this. But then if you actually want a code that is a little bit readable and a little bit more beautiful, because someone said that a lot of else in Go code is not really something that is not really idiomatic Go. So a very good way to go about it is just simply put a continue here. And then after the continue, I can do total to be plus or equal to n. So this way it looks more clean and more beautiful. So if I run this code now, I'm still going to get the same result. So a is not a number and 8. So this, what is happening is actually after this particular the for loop which gets to a, or the value gets to a, because a is not a number, just simply print this. Then continue says don't do anything after, then just go back. So it just go back to the next number, which is basically 3, then 4. So that is actually how continue works. So the next one we'll be looking at now is new versus pointer return. So for this one, I'll declare a type person and I'll call it a struct type. So you just have a first name and a last name, both will be strings. Then I'll have a function that will help me create a new person. I'm just taking the first name and the last name, and they are both strings, and to return a pointer to a person for me. So I'll just simply do a check here that if the first name equals to empty string, that means if there's no first name specified, or the last name is equal to an empty string. So I don't want to return a pointer to person. If that is not the case, I'll just return a pointer to a person. Then the first name will be the first name here, and the last name will be the argument passed into last name. So this is basically what it is. So here I'll call I'll just create p to be new person, then I'll pass in this, then I'll pass in this. So I'm passing both the first name and last name as empty strings, then I'll print p. So let me clear out my console, format the code, and then run it. So string of, I need to take this out because I'm no more using it. So once I take this out, the code runs now. So now I'm having an empty pointer. So it so happens that I can actually return nil also in this place also. So it's still going to work. So this time around when I print, I'm getting, so this time around I'm getting nil. So you might ask that when is the best time to use nil and when is the best time to use pointer. So the way I actually do it is that if for some reason the code I'm writing, I actually need the person regardless of if the first name or the last name was specified or not, I can just leave the code this way and actually just return an empty pointer, because regardless of what happened, I still need the person. So I can actually do this. Or alternatively, I can actually just clear this, because this in a way actually still means the same thing. So if I need the person regardless of the direction the code goes, so I can leave it this way. But if for some reason I actually want to I actually want to make sure that the person must actually have a first name and a last name for some reason, so I can actually just modify this code and actually just do an error return as the second value. Then I can backtrack. Let me backtrack the code. I think it will be easier to work with that way. So I can just actually do this and actually make a second return value, which will most likely be an error. So I can actually do this, then I can actually return nil in this case, because I'll be doing some error checking, which I'll most likely be panicking or returning if there's no first name or last name specified. So I can just say first name or last name not specified. So if I call this function new person, else return this and new. So once I call this function new person in my package main for my function for example, I can just call the error also. So it should be new person this. Then if I say if error is not equals to new, then I can just do some error handling. then I can just return from the function, or I'll just panic the error or something. So that way, because I actually want to make sure that regardless of whatever happens, there must be a first name and a last name. So I can actually go through this way. Since I'm returning an error, I'm actually just returning as the pointer, because I won't be using it since there's an error. But if it's the other way around, whereas I actually need the person, regardless of if the first name or the last name was not specified, we just go through the first way. So we just simply just change everything. We just leave the function like this, and we take this out, and we take this out also. So that way, so that's how it is. So the next one we'll be looking at is invalid memory or new pointer at the reference. Okay, so let's say I have a type data struct, and it has just one field, val, and the value is basically an int. So I actually want to declare a sorry, so I want to declare a method that actually work with this type data. So I can actually just do func, and this one will take in the, which is pointer to a data. Then what this just does is just double the value, or just add to. So what this does is to return an integer. So it just simply returns d.data plus 2. No, d.value, sorry, data plus 2. So in my func main, if I do a variable d of type pointer to data, then I do from print main d dot add 2, and then I run the code, clear out the console, format, then run. So what I get is this error, invalid memory address or new pointer at the reference. So the fix to this is just simply just change this to var_d should be equal to a pointer to a data. Then if I do this, this should work this time around. So I'm having to, because initially when d was actually declared here, the value of val will be equal to 0. So I'm just doing 0 plus 2. So what this add to does is does 0 plus 2, which is basically 2. So another way to actually do it is just to like ignore the old pointer thing and just use the value, because remember that pointer receivers will actually work on both pointer types and value types. So you can actually just do var_d of type data. So this should work also. So it is working also. So that is just the two fixes for that. Then the next one is new map entry. This one is a very funny one, which I don't know, but most likely every good developer at some point has actually came across this one. So if I declare a variable m, which is a map of string to int, just take this out, and I do m of 1 should be equals to 1, then I print m, and I try to run the code. So clear the console first, format the code, then run. So I'm getting this panic assignments to entry in new map. So the reason is because when m is declared here, because I didn't actually assign a value to it, it's actually a new map. So to fix this, I can just simply do var m should be equal to map of string to int. So this should work. So now it is working. Or alternatively, I can just use the make keyword to just make my map. So instead I can just do make, then I'll take this out, then this should work also. So it is good like that. So let's say the map is actually a map of, so instead of this, if it's actually a map of string to map of string to int, and I do m of 1 of 2 should be equals 12. So I'm still going to also run into the same error. Oh sorry, I should have printed m. So I'm running into the same error like before, assignments to entry a new map. So the way to fix it is actually just to like, because what I actually did here was actually initialize the outer map, but I didn't initialize the inner map. So to initialize the inner map, I have to say the outer map should also be equal to make the map of string to it. Then I can now do m of 1 of 2 should be equals 12. So this way should work now. So now it works. So that is the fix. Then the next one is assigning a slice to new. So this one is a very funny one. So let's say that you're actually working on a particular piece of code and you're actually doing a lot of emptying of string, then inserting value into emptying of slices and inserting value into slices and emptying it and inserting. This one is something that actually, if you're not careful, it can actually have memory implications on your code. So let's say I have s to be a slice of integers 1, 2, 3, and 4. So it so happens that if I print s, so I can print x, let me mean xi, slice of integers. So to empty it, I can actually say xi to be equals to an empty slice of int. Then I'll just copy this place and paste it here. Format, then run. So at first I have this, then when I clear it out I have this. So it so happens actually assign this to nil also. So it still works, I still have the same result. So which one is better? So for the sake of this video, I actually say this is actually better. And the reason is because if you go through the first method where we have this will actually clear out xi fine, but it will actually release the underlying memory to the garbage collector to get garbage collected. So if you are doing a lot of emptying and appending and emptying and appending, over time you might run out of memory and your code will crash. So the best way to do this is actually just assign it to new. So it's actually a better method to do things. So that way you know that once you empty it, the memory it is holding will get assigned, will get pushed to the garbage collector, and it will get garbage collected and all. So the next one is slices and maps automatically pass by reference but arrays by value. This one is a funny one. So normally if you actually pass by value, to pass by value, say I have a func foo that is taken in n, which is an integer. So what it does is basically doing is actually assigning n to 7. So change value of n to 7, then I can create a variable n to be 5, and I print n, then I call foo on n, then I print n again. So I'm having n to be 5 twice, but foo is meant to change n to 7, but it is not. The reason is because I'm actually passing n by value. So to actually make the effect on foo, they actually make foo to take effect on n, you just have to pass n as a pointer. So that way I'm passing by reference. So I'll just do ampersand n. Simple. Oh, sorry, format print in n, then foo ampersand n, then print n now. So if I do this time around, oh, I should actually dereference it here, pointer to n. So when I run this now, so I'm getting 5 and 7, fine. But for some reason, slices and maps, once they are passed by value, they automatically pass by reference. So I'm going to change this one to a slice of int, and I will say x of I into brackets, let's change the first value to be equals to 8. A slice of int. So I can do xi to be equals to a slice of int 1, 2, 3, and 4. Then I can print x of I. Then I'll do foo x of I, and I'll print it out again. So this time around, if you notice, I'm actually passing x of I as a value. I'm not passing it by reference, I'm passing it by value, but for some reason it still affected it, and that's because slices and maps are actually automatically passed by reference. So that's what you need to be careful about, but arrays are not. So you can actually change this to a map also. So let's say that I'm having a map of string to int. Sorry for my naming convention now, so you can actually give it a better naming. So I can just say this is actually a map of string to int. So I can just do m of 1 should be equals to 3 this time around. Oh, m si of 1, let me just make it m so we won't get confused. So m of 1 should be equals 3. So I'll actually declare a variable which is a map or string to int, and 1 should initially be 1. So I'll print out m, then I'll call full on m, then I'll print out m also. So initially m was actually a map 1 1, but now it's a map 1 3. So because of also maps are also passed automatically by reference, not by value. So that's another thing that you should take note of. So the next one, but arrays are not. So if I just backtrack my code, so I just make it an array. So I just make xi to be an array of ints. I just taking 3 values. I can say x of 0 to be 8, then I'll change this one to 3. So I can't add a fourth value because I only hold 3 values. So if I do this, so unlike the slice that is supposed to like change the first value to 8, this time around it is still 1 to 3. So arrays actually pass by value, but slice and maps are passed by reference. So if you actually want to change the value for an array, you have to pass it by reference. So next one is variable shadowing. So this one is something that we as programmers actually come by a lot. So it's something that you cannot avoid as a programmer. At some point you come over variable shadowing, and it's most times unknowingly. So let's say I actually have a variable n to be equals to 3. So I'll say if true. So I can now say n equals to 1, then n plus plus, then out here form to print ln n. So at this point I actually incremented n here. So I was meant to actually have 4, but then look at what I have. I'm still having 3. Why am I having 3? Because I actually shadowed it here. I've actually shadowed this particular variable n here, but for some reason the compiler won't tell me because it's actually a logical error. It is not a syntax error. So because I actually shadowed this, and this is not actually in Go alone. I've actually come across something that is also in JavaScript also, and JavaScript is even notorious for variable shadowing. So you have to be very careful with variables. So that is how it is with variable shadowing. Then the last one we'll be looking at is copy minus be copy. So I forgot where I actually saw this name from. Copy minus be copy, use append instead. So what I actually mean by copy minus be copy is, say I have a variable source to be equal to a slice of integers, and I want 1, 2, and 3. Then I have a variable destination, which is just basically a slice of integers. So I want to copy from source to destination, so I'll just use the input copy from the destination to the source. So then I'll print out destination. So actually I'm meant to have 1, 2, 3 in destination, but if I actually run this, I'm having destination to be empty. So the fix for this is just simply to just use append. So you can actually just use append instead of copy. So I can actually do dst should be equals append dst, then I'll do source, then I'll unfold it. So this way it should work this way. So I'm having 1, 2, 3 now. Or another method is just to actually use the make function to actually build destination. So I'll say make slice of int, then the minimum length will be the length of source. The initial length will be length of source rather, not minimum length, initial length. Then I can just simply do my copy back. So I'll copy back from destination or from source to destination. So I'll format the code, then I'll run it. So this time around this is working. So that is basically all I have for now. I might do a part 2 of this video mentioning other gotchas and quirky syntax, but at the time I was recording this video, these are the ones I have. So before I end the video, I would like to mention that if you have actually come across any of this in your journey as a Go programmer, comment down in the comment section below that I came across this. And also, if you are new to the channel, make sure you subscribe once more. And if you're not new to the channel, if you're actually watching videos from this channel and you haven't subscribed, I would really appreciate it if you consider subscribing. Very important. So that will be all for this video.